Welcome to Maths for You channel. Graph sketching for modulus functions, modulus equations. Sketch the graphs of x equal 3 minus modulus x and y equal modulus x minus 1 in the same diagram, same axis. Hence or otherwise, it's a strong hint. The first part will help to solve the second part. Find all real values of x satisfying the inequality modulus x plus modulus x minus 1 less than or equal 3. So the first equation which we have to sketch a graph is y equal 3 minus modulus x. And the second equation, y equal modulus x minus 1. It's the modulus involved, so we need to is for the x, the minus and plus format we have to use. For the first one, because of the modulus for just for the x, not 3 minus x. So I just wanted to bring that 3 to the left hand side, this y minus, and then take that as the new y's. Just imagine that as y. Just put fx instead of y, fx. So the y minus 3 is the fx. That is equal minus x. So all I did, just ignore the modular signs. So just put the sign minus and x. And same for this one. This one is all in modulus sign. Therefore, y equal sgx equal x minus 1. Just remove the modulus. Then think about how we're going to approach to sketch the graph. Y minus 3 is simply, I just want to imagine that's the new y. If that's the case, you can imagine it, but we need to sort of represent that where that new axis is. So if you have a axis, just a normal axis, say like that, this is x, this is y. So y minus 3, a line y equal 3. So that's so if this y equals 3 is the new axis. So so we just think about it that we're going to draw the or sketch the graph on the basis of y equal 3 as a new x-axis and y-axis is still the same. So if you think about that, we know the standard form or standard graph, a straight line graph for minus x, which is this way. So this is equal y equal minus x. Then again, I just wanted to sort of go through a bit more detail for this, how I am going to sort of approach this graph. When x is positive because of this is 0 is the pivot point. This point is, this is what, 0, 3. That's the pivot point. So x is positive, the fx is fx. So it's just, there's no changes. So minus x, that is what I actually have drawn. And if it's less than or equals 0, that's this one, less than or equals 0, fx equal minus. What this is, the reflection of that fx on the new x-axis, which is y equal 3. That will be positive. So just minus fx means minus to minus plus positive. So if you have a straight line for y equal x, that's simply this one. So the graph, this is equal y equal x. So the totally, if you look at that, the total graph, the total sketch is for 3 y equal 3 minus modulus x. So we just analyze it such a way that remove the modulus sign and bring the 3 that. So having done all that, so that the graph we have sketched is y equal, the whole lot is y equal 3 minus modulus x. We can look at it here. So I just put the sketch here. So this part, this part fx minus x. So this is the minus x, and this, the left hand, this part, this is minus x, and this part is minus fx, that's equal x. So the whole thing is the y equal, that's if you look at it here, if I put y equal 3 minus modulus x. This is graph done. So the pivot point here is the pivot point for that graph. So because of the left-hand side or left-hand side of the y-axis is reflected, and then that's we know that x equal, minus fx equal x. That's done. So the second one we look at it. As I said, y equal gx, that is x minus 1. When x greater than 1, because of what we need, what the pivot point when we have to find, x minus 1 equals 0. Here x equals 0. This one, the second one, x minus 1 equals 0. That is x equal 1. That is the pivot point. So the pivot point we could as a reference. So 1, 0 is the pivot point, and then anything greater than that, anything greater than 1, that the graph is same as x minus 1. So x minus 1, this is the graph, x minus 1, y equal x minus 1, or gx equal x minus 1. And then after that, x less than equal 1, the gx equal minus a gx, which is the reflection of that gx over x-axis. So that is this one. So what it is, y equal minus minus x minus 1. That will be minus x plus 1. You could simply that as this the graph is going from left to right and reducing it. So this one is x minus 1, this one is minus x plus 1. So both done, but if you look at it, they are cutting each other. I mean, the two graphs, two modulus graphs are cutting each other. So the first part done, the graphs have been sketched. So the second part, otherwise, hence, I don't want to use the otherwise, hence, find the real values of x satisfying the inequality of that. So inequality of that is modulus x plus modulus x minus 1 is 3. But what I want to do, I wanted to sort of make it as the first part. So the first part, if you do make the first part, x minus 1 is a one graph, isn't it? So the modulus x minus 1, I take that modulus x to the other side, 3 minus modulus x. So we have both graphs. So this is the first graph, this is the second graph. So the first one, the graph, if you look at the first graph, is greater than the second graph. If you look at the first graph is greater than second graph, this part, this about this area. So this one, this area is greater. After that, it's less. So this is the area. So from if you crossing point here, if I could construct that to x-axis, that actually meet x here and y here. So between x and y is the first graph is greater than or equal second graph. So let's look at to find the value of x or the coordinate of x. So point x, I just took it. Then point x, there are two graphs we need to consider. One graph is y equal minus x plus 1. The other graph is y equal x. That's two graphs. So y equal, if it's plus x, that means y equal 3 plus x, because of that is x. So y equal 3 plus x. And the other one is y equal minus x plus 1. That is here. Then so this graph is there. That graph is this graph is here. This graph is there. So we have got that here. Y equal 3 plus x. That's the first graph on the left hand side. And the y equal minus x plus 1 is the second graph on the left hand side as well. The on the left hand side of the pivot point. That will actually give us the point x, the coordinate of point x. So if you look at it, if we satisfy this y 3 plus x will satisfy this y equal x minus x plus 1. So 3 plus x equal minus x plus 1 2x. If you take the x to the left-hand side, 2x equal. Take the 3 to the other side. Minus 3 plus 1 is minus 2. Therefore, x equal minus 1. So x coordinate we have found. So the one limit we have found where that the first graph is greater than 3 minus modulus x greater than or equal x minus 1, or in other words, modulus of x minus 1 less than or equal 3 minus modulus x. That's done. Now we have to find the point y coordinates. For in y coordinates, if you look at it, there are two graphs here. As one is the x minus 1, the other one is minus x. So x minus 1 minus x. But if it's minus x, y equal 3 minus x. If it's x minus 1, the second graph, y equal x minus 1. So if you could x minus 1, if you could one another satisfy. So x minus 1 equal 3 minus x. Bring the x to this side. This is 2x. And take minus 1 to the other side. It will be 4, 2, 2, 0. So the xy between the limit x and y, that the condition we need to prove that is when the first graph is greater than the second graph. The first graph value is greater than the second graph values. So the limits, therefore, x must be between minus 1 and 2. So x must be greater than or equal minus 1 and less than or equal 2. That's the answer. So we have the graph is heavily helped us to find the second part. That is exactly the set. Hence, otherwise, don't, when they say hence, the students should understand the hence will, just that's the one they have to go for. So wait, trying to get that the first part will help. Only a little thing you have to do here is modulus x plus modulus x minus 1 less than 3. So that's the little confusion. But if you take that, the modulus x to the right hand side, now we have two graphs, which we have the sketch for them. That sketch will help us to find the limit where the first graph is greater than the second graph. Thank you. Please subscribe the channel and share the contents with other students. Thank you.